Good day, I'm Dr. T, and welcome to my office. Let's talk about atoms first. So this is going to be fairly specific. So if you're not a chemistry educator, this is maybe slightly interesting to you, but definitely kind of off topic, so maybe not your top video choice from me. But the idea of atoms first is kind of the buzzword, the big kind of cool thing in chemistry education for like the last 10, 20 years. I don't remember it not being the new cool thing. And the idea here is we're talking specifically about general chemistry education. And this is really fairly narrow. This is really only talking about what order do we teach topics in. In particular, where do we put in the unit or in that semester the part where we talk about ground state electron configuration, orbitals, basically applied quantum physics, periodic trends, Lewis structures, and that kind of stuff. So in traditional chemistry, or the traditional way of doing things, the way that most textbooks are set up, but this is changing. Chapter 1, maybe chapters 1 and 2, I'll call it chapter 1, but it could be split into 2 chapters, is usually this is what chemistry is, this is what dimensional analysis is, these are units, etc. Then chapter 2 is going to be, this is an atom. These are protons, neutrons, and electrons. These are isotopes and ions. Fairly straightforward. Now here's where the split occurs. In traditional structure, then you would have chapter 3 would be naming and nomenclature. Then that would blend into chapter 4, which would be reactions. Once again, books will shuffle things around. But chapters 3, 4 will be naming, reactions, that kind of things. Then chapters 5, 6, and 7, in no particular order, are going to be things such as gases. Good old ideal gases. Usually doesn't get too much into the real gases, although usually there's a blurb on real gases. A bit into solutions. Typically molarity. All the other fancy units are usually kicked to second semester, although you might get percentages in there. And then you're going to do thermochemistry, so you're going to do things like specific heat and delta H. Delta S and delta G usually get kicked to second semester. And then you're going to do the applied quantum physics section. Orbitals, Lewis structures, periodic table trends. So not just periodic table, that's usually covered in chapter 2. So it's like here's periodic table, the columns and rows. This is the metals, this is the non-metals. That kind of stuff is chapter 2. But now all of a sudden it's going to be like, okay, so as you go across the period, your atomic radius is going to decrease. That kind of stuff is usually in chapter like 8 or 9 or something like that. And that's usually where you end for the semester. In Atoms First, it's going to be the exact same content. If you look at an Atoms First textbook that also has a traditional version of that textbook, OpenStax does this. I mean, it's literally, they just move the chapters. There's very little else changed. You're going to take those quantum physics chapters, the last 2 you did in traditional, you're going to move those to right after when you first covered atoms. So instead of being 8 and 9, they're now 3 and 4. And this way, you go units. Here's what an atom is. Now here's what the crazy electrons do. Hey, they're a wave particle. Yay, all that kind of exciting stuff. Periodic table trends. At the same time, you're learning about the periodic table. So it's like, okay, you learned that the groups, the columns, all have similar chemistry. And you learn about valence electron shells, which is why they have similar chemistry. And so everything kind of ties together. This is why it's kind of the newer approach. It makes a lot of sense to cover just all of the atom stuff together. And then once you're moving on to nomenclature and naming, you can take somewhat more confusing ideas like the octet rule, which really doesn't exist. There's no real octet. It's all orbitals. Well, if you already know the orbitals, your S and your P's, you understand why there's an octet. You understand the why of the 8. So you can just take the octet rule and chuck it. You don't need it. And therefore, you don't have to deal with all the weird exceptions. It's like, but helium should have 8 electrons. No, it only gets 2 total. And if you understand, it's like, well, it's just got an s orbital because it's the one s orbital. That makes sense. And in things like expanded octets, Hey, how can phosphorus have that many electrons? Well, let's think orbitals. Although it gets a little bit confusing with the d orbitals because it looks like the d orbitals don't actually do anything. Yay, quantum mechanics. Now, this is a great approach. There is a couple of downsides. One, it's not the original way. And once something becomes traditional, it kind of gets ingrained and rooted in. That's typically why you don't try move things from second semester into first semester. There's a lot more tension when you try and do that because now you're redefining what first and second semester general chemistry are. And that's kind of, if your students don't transfer, that's fine. If your students transfer, that's a problem. But also, Atoms First typically messes with your labs. In the traditional setup, it transitions nicely with your laboratory work. So you learn about units. You're probably going to do some kind of density lab. Now you learned about atoms. You're still probably doing the density lab. Now you're learning about naming and chemical reactions, so you're going to go ahead and do a chemical reaction. You might have law of conservation of mass, where when you do a chemical reaction, you don't actually do a chemical formula because you haven't quite got there yet in the lecture, but you're going fairly straightforward. So the second or third lab you do can very easily be a full-fledged chemical reaction, and you can do some legit chemistry. Well, Atoms First, you don't get to chemical reactions until basically the midterm. So now all of a sudden you've got a full half semester almost, where you can do a density lab. A flame test would work great. If you want to crack out some molecular model kits and do some molecular geometry, well, you're covering that. But you can't actually do any chemistry per se. I mean, you could, but you're definitely deviating from the lecture part if you're doing that. Which sometimes it's fine to deviate from lecture part with lab. It's never ideal, but it's sometimes okay. Yeah, so this creates a little bit of a problem. Now, if you do want to do the molecular geometry stuff, okay, more power to you. That's not a big deal for you. If you're doing Write Like a Chemist and other scientific writing material, which, by the way, if you're not familiar with the book Write Like a Chemist, you should be. It's a great book for chemists. There's a few other books for more general scientists, but Write Like a Chemist, it's in the title, How to Write Like a Chemist. It's a writing book for chemists. So if you are doing scientific literacy, scientific writing, and you're doing that in the first semester, you have time. This would be a great spot to do this. And then once you've done that, you move on into your labs. Now, you're probably going to have to cut a few of your chemical reactions or shorten them up a bit because, well, you just cram them into the second half of the semester. So there are some logistical issues with Atoms First. I won't lie. I won't deny that. Now, I've been doing Atoms First with my GOB course for really about a decade now. I've kind of trended that way before I moved to my current school, and then really at my current school and my whole time here, just about. It has been Atoms First because it just makes sense. But once again, it does make the labs harder, and I do have to kind of sit back and go, okay, how do I fit a lab into this early spot before we've really done a lot of chemistry? Which is, inconvenient and not ideal. But I think it's more than made up by the fact that you're in a much more coherent order of topics. It makes much more sense to talk about periodic trends when you're talking about the periodic table instead of a few months later after you've kind of forgot about it. So if you are teaching general chemistry in the first semester, you've got yourself some options. Traditional or Atoms First. I like Atoms First. It's a great approach, but you do have to think about your lab before jumping into Atoms First. With that said, have a wonderful day, and I will see you in later videos.